Hello everyone. Today we will be starting very important chapter of engineering maths. The name is integral calculus. Calculus, whenever we hear this word, it's one branch of mathematics, like how we studied the geometry, means we study different geometrical shapes, and algebra, then we study the expressions, algebraic expressions in that. Similarly, here when we hear this word calculus, it's one branch of mathematics where we do the study of differential calculus as well as integral calculus. There are two parts, two branches over here. So, in differential calculus, we do the study of rate of change of function with respect to time or some other quantity, and in integral calculus we do the study of area under the curve. So, basically it accumulates all the values over the period of certain functions value. So, that is what the difference between these two branches, differentiation calculus and integration calculus. Most of the quantities in differential calculus, for example, which I will tell is velocity when we measure, like change of any quantity with respect to time, like velocity, like distance change with respect to time. That is how we calculate it. That is nothing but a change of quantity with respect to time. That is nothing but differential calculus. That kind of situations we study under that. In integral calculus, we study about the area under the different curve or to accumulate certain quantity. So, first of all, I will start with application of integration and how we use it in life where it gets used. So, for example, I would say here I have taken here the one area. It's enclosed area. It's basically it's not any definite shape, or it's not any geometrical shape like which normally we consider, like it's a rectangle or triangle or square, regular geometrical shapes where we know how to find its area. So, for those geometrical shapes we know how to find the area with some formulas has been given, each depending on what kind of shape it is. But what if the area doesn't have in any fixed geometrical shape? For example, if you want to find the area occupied by area of certain village, so it won't be in specific geometrical shape. So, how you will be finding it, because there is no such formula, exact formula you will be able to apply, like how you find with rectangle area like length into breadth, such kind of formula directly you won't be able to apply. So, how you find the in those situations, how you are going to find the area of that particular region or whatever you are considering. So, in those cases how we can do it here, this whole region, this like for example, I want to this shaded area with stripes, I want to find the area of this particular region. So, what I would do it, this whole region I will divide I will take the strips like this. Basically, the whole region I will be splitting or dividing into different strips or the rectangles here, and I can find the area of this rectangle, because see, if I will take this one, I can take this as a rectangle. So, each rectangle like this 1, 2, 3, 4, and I can find its area by using certain formula like length into breadth. But what if there is a gap over here which is getting we are not getting into consideration that gap. So, what I can do it here, then we can do it, we can make more smaller or thinner strips over here, so that we can occupy this the area which are not getting considered, that also we will consider it. And so the in short that strips are becoming thinner, and it is going very small, like over the, if you keep going on that slicing of this each of these strips, it will come to point where it becomes very close to 0 or some value it will be there. So, what we will do it over this, then we will find the area of and one more important thing is the width of each of the strip will be equal, it will be same, and then we will find the area of each strip, and what we can do it, we can integrate those all the strips. Integration is nothing but accumulating. Accumulating means nothing but we are adding that over this whole region. So, that is why we are taking this limit from A to B. So, and we will be adding all the area of all these strips together, which will give you finally the area of this enclosed shape. Basically, this is irregular shape which does not have any specific geometrical shape. So, that is how it is quite useful whenever you want to find like area of certain irregular shape. Like for example, if you will say, if you look at the India's map, so that it is not indefinite geometrical shape or something like that, but if you want to find the area of such things, then integration is quite useful for that. So, this is about application of integration, it is quite important. Now, when we here while studying this integration, we need some formulas. From this, I have made one list over here with the formulas which we will be using throughout this chapter. So, most of the formulas you have been used it in 11th, 12th grade, definitely you have used it, but to make you go through or to revise it, I have put all of them here together. So, we can just quickly overlook it. So, here first one is x raised to n is integration. If we will do it here, integration of x raised to n, it will be x raised to n plus 1 upon n plus 1, and you know it, c is nothing but integration constant, which we are going to put it everywhere because it is a again it is a indefinite integration. So, we do not know the limits of that integration. Whenever we do not know the starting point, ending point, that time we always put that integration sign. We will study that, you have studied it in 11th, 12th also. So, now integration of 1 upon x dx is equal to log x, e to the power x integration is the same, e to the power x, sin x integration is minus cos x, my cos x integration sin x, sec square x integration will be tan x, sec x tan x integration sec x, cos x square is integration will be minus cot x, cosec cot x integration will be minus cot x, minus cosec x, and there are these formulas which we have been using, like whenever we see that 1 upon 1 plus x square, that is integration, its integration will be tan inverse of x. Similarly, 1 upon x a square plus x square, that will be giving 1 by a tan inverse x by a. Now, 1 upon root a square minus x square, integration will be sin inverse x by a, e to the power a x integration will be e to the power a x upon a, then sin a x integration will be minus cos x upon a, cos x a x integration will be sin a x upon a. Comparatively, if you look here to the other formula that are quite, you can understand the difference. So, these are basic formula which you most of the formulas I believe you know it, but still it is we will be using. So, it is useful to have them together. Let us take a small break over here. Meantime, you can revise the concept. In the next video, we will be discussing this more in details.